Okay, good morning, everybody. Review continues today, so let's go ahead and get warmed up. Today, we got three problems very similar to what we'll be talking about today. Essentially, the things we're going to review today is how to solve a quadratic in general. So there's lots of techniques. There's factoring, there's completing the square, and if all else fails, you can always turn to the quadratic formula, which completes the square for you automatically, which is kind of nice. So let's go ahead and do our warm-up real quick. Number one, we're supposed to solve this by factoring. So we have a cubic equation. That's not what the point of this unit is. It's not about things with raised to a third power. Nonetheless, it still does break down to a quadratic because what goes into everything? Well, there's numbers. What numbers go into everything? 3. Yeah. Well, there's a letter too, right? X. So a 3 and an X. And I'm going to factor the 3 and the X out. It's usually good practice. So you don't have to do this, but it's good practice also to factor out anything in the front that's a negative also. So if front's a negative, why not factor that out also? So I'm going to factor a negative, a 3, and an X out. You don't have to factor that negative out, but at least the 3 and the X. You factor the negative and a 3 and an X out. Well, from the first term, the negative's gone, the 3 is gone, and one of the X's is gone, which just leaves you with an X squared. That's why I factored the negative out. So the next thing I was coming down the pike is going to be an X squared thing. I like my X squared things positive. Next term, if you factored a negative out of a positive, there'd be a negative left over. If you factored a 3 out of a 15, there'd be a 5 left. If you took an X out of 2 X's, there'd be 1 left. So 5X right there. And lastly, if you take a negative out of a negative, that'd be a positive. Take a 3 out of 18, that's a 6. And there's no X's left remaining in that term because you took the X out. So first step looks maybe something like this. And if you didn't factor the negative out, that'd be okay. You have all these signs would be different, but you'd have to think about how to factor that thing. All right, does this thing factor? Let's think about it. Anything that multiplies to be 6 adds to be -5. Any ideas? Yeah, -3, -2. Yeah. So X minus 3 and X minus 2. And the whole point of factoring is no matter how many factors there are, 1, 2, 3, 20, doesn't matter. Each of them, I see 3 things multiplied together. Here's a thing, here's a thing, and here's a thing. I'm going to figure out when these things themselves are equal to 0. So one equation is when is -3x equals 0? Well, to get rid of the -3, you just divide by -3. 0 divided by -3 is still 0. So that particular factor gives me x is 0. The other two you could just spot. If x minus 3 is 0, then x is probably 3. And if x minus 2 is 0, then x must be 2. So there's 3 answers to this problem. Not a coincidence, it was a 3rd-degree polynomial up there. But that brings me to another point. If you have quadratics, things that are squared all time powers of 2, you should always get 2 answers out like that. So that's factoring, basically. Take out things that they all have in common. And whatever's left, you have lots of techniques. If it's a quadratic, try to factor it like that. 2 things that multiply to be the last term and add to be the middle term. So that's basically it about factoring. I don't got much else to say about that. We'll zip through that real quick in the review. Number 2 is very similar. We're going to have another quadratic equation. It says 2x squared minus 6x plus 7 equals 0. Doesn't look very easy to factor. So the one thing you should probably try to do is something called completing the square. And I will give you this equation during the test. Okay, you just got to follow it religiously. If you can get something to look like this, x squared plus a number times x or something like that, then you can use this formula right here. Problem is, this doesn't have an x squared. It's got a 2 in front. So again, remember when you're completing the square, and there will be a few problems on there where that's mandatory. It's like you have to complete the square in order to solve this. You just focus on the first 2. And in order to get to look like that, if there's a number in front, like a 2, you need to factor out of both of them. So I'm going to factor a 2 out of these first 2 terms. I like to put brackets. You don't have to put brackets. You can put parentheses. I just like to put brackets. That kind of signifies to me, hey, I'm going to complete my square inside these brackets. So take out any leading term that might be there. That way it matches the formula. And if it matches the formula, you just got to literally match the formula. Here's -3. Here's b. B is -3. So I'm going to replace this expression with this one over here, equivalently with b being -3. So I'm just going to copy this down with b being -3. Of course, the 2 is still outside. Inside of here, using my little formula, it's going to be x plus b over 2. B was -3. So plus -3, you could just say minus 3 over 2. There's b over 2 right there, negative 3 over 2. You have to also take away, when you're completing the square, whatever that term is, in our case, negative 3 halves squared. So I'll just write that right here, negative 3 halves squared. Close your bracket, because the bracket was where you were changing that expression. There's still this 7 awkwardly on the end. And we're done with that. Any questions about how we set up the formula or used it or anything like that? Okay. Well, let's proceed. Lots of things you can clean up from here. First things first, I see a fraction squared. Now, don't be scared about that. Let's just figure out what that squared is. What is negative 3 halves squared? So off to the side, maybe I go say, oh, what's negative 3 halves squared? Well, to square something literally means to multiply it by itself. So multiplying a fraction by itself, how do you multiply fractions? Straight across, right? Yep. So negative 3 times negative 3 is 9. And 2 times 2 is 4. So this expression right here is just 9/4. So I'm going to call that 9/4. Why not? That's a little cleaner. The minus sign in front is still there. Still got a minus 9/4 because the equation had a minus. All right, that's a little better. The whole reason you factored the 2 out in the first place was so you could use this stupid formula. So you used the formula, you cleaned up a little bit, time to put the 2 back in. When you distribute the 2 back in, it has to go to both this term and this term right here. Be very careful about that. The first one, there's nothing you can do. It's 2 times this thing squared. And you're kind of just stuck with that. You know, you can't put the 2 inside this thing because this thing is squared, so it doesn't work that way. But you can do 2 times 9/4 real quick. So off to the side, what is 2 times 9/4? Well, 9/4 times 2 is 18/4, which reduces to 9 halves. So the 2 times the 9/4 is 9 halves, and there's a minus sign, so it's minus 9 halves. Still got the plus 7, all that jazz. Doing just fine with it. Now, I know this sucks, but these are like terms. You know, they're just numbers. We can add them together. We can take negative 9 halves plus 7. So let's figure out what that is. Negative 9 halves plus 7. Well, I got to add fractions. How do you add fractions? You need a common denominator. So 7 apparently is the same thing as 14 over 2. So negative 9 halves plus 7 is negative 9 halves plus 14 halves, which is just 5 halves. So I'll just call these two 5 halves right here. 2 x minus 3 halves squared, and then plus 5 halves when I add those together. Negative 9 halves plus 7 is 5 halves. It's slowly whittling down to something shorter and shorter and shorter, where we'll get ourselves an answer. The whole point of this is to get x by itself. If you remember what we're trying to do is trying to solve for x. So we're trying to get this by itself. We're going to get the squared thing by itself. We'll move the 5 halves to the other side. And if you move the 5 halves to the other side, then it becomes a negative 5 halves right there. We're slowly getting this thing by itself. There's a 2 in front, though. How should we deal with that? Well, let's divide by 2. So we'll divide this side by 2. And we'll divide this by 2. Now, how do you divide by a fraction? You don't. You multiply by the reciprocal. So negative 5 halves divided by 2 over 1 is the same thing as negative 5 halves times 1/2. Keep, change, flip. Notice how all our fraction rules came up? We had to add them, we had to multiply them, we had to divide them. So lots of things happening here. That's going to be negative 9 or negative 5/4 when you go ahead and multiply those together. So now I got this thing squared is equal to negative 5/4. And finally, we're ready to undo the square with a square root. Do not forget your what? What do I yell about all the time when you take a square root? Plus or minus. Do not forget that. Please do not. I can do this in pieces. Let's see. I'm about to take a square root of a negative. What kind of number is that going to be if I take a square root of a negative? It's going to be imaginary. It's going to be an I. If I look at this fraction, square root of 5, that's not pretty. There's nothing that goes into square root of 5, so we'll just leave it as square root of 5. But on the bottom, square root of 4 is pretty. Square root of 4 is just 2. So we can take the square of the top and bottom separately like that, nice and pretty. And lastly, we're just going to add the 3 halves over. That makes it a positive 3 halves when we move to the other side. So the final answer is x is 3 halves plus or minus square root of 5 all over 2 times I. It's a disgusting answer. but is in fact correct. So that just took a lot of work right there. I think I'll give you maybe one like that on the test. And I kind of have it, I'm going to design it so it's probably not going to be fractions. I'm not going to kill you with fractions. You should be able to do it with fractions, but nonetheless, I will give you probably one problem where there's something in front that's not just a 1, like a 2 in front or something like that. But it should work out relatively painlessly. As long as you understand the process, that's a lot more important. Factor out the first thing, complete the square, put the first thing back in if you need to, get the square thing by itself and undo it with the square root. That's the whole darn point. Okay, lastly today, number 3, quick and easy. Solve by using the quadratic formula. So they give you this equation, negative x squared minus x plus 8 equals 0. But they also want you to first find the discriminant. So what is the discriminant? Very good. The stuff in the square root. So this thing right here, b squared minus 4ac. So let's do that real quick. What is b squared minus 4ac? Well, b is negative 1, right? Negative 1 squared is positive 1. Whenever you square something, it should be positive, right? Negative times a negative is a positive. Positive times positive. Minus 4ac. 4. A is negative 1. And c is 8. So if you go simplify that a little bit, first thing I see over here is I got a negative and another negative, right? 2 negatives make a positive, so it's really a plus. And 4 times 8 is just 32. So this discriminant turns out to be 33. If you look at your little cheat sheet, and you might want to look that over before the test or something like that. When your discriminant is positive, that means that your graph will cross at 2 real spots like that. So what this tells me is that there's going to be 2 real, distinct, they will be different. There's going to be 2 different spots where that occurs at. Will they be rational or not? Will they be pretty fractions or not? Well, that comes down to whether that number is a perfect square. If you look over here, 33 is not a perfect square. So that turns out to be irrational. That's just a fancy word for can't be written as a pretty fraction. It's going to have weird roots in it or something like that, square root of 5s and things like that. Okay, that's it. So there's going to be 2 real distinct zeros if I go ahead and do this thing. They're going to be irrational. They're not going to be pretty. Let's go ahead and do the quadratic formula now to confirm that. So doing the whole thing and actually figuring out what the answers are, here's the quadratic formula. It says x equals negative b. B was negative 1. Negative 1 would be positive 1. Plus or minus the square root of the discriminant, which we already found. It was 33. And that's all over 2a. A was negative 1. So that's negative 2. And as promised, they're real. I don't see any eyes floating around. Do you? I don't see no eyes. They're distinct. There's 2 answers. One is 1 plus the square root of 33. The other one is 1 minus the square root of 33. They are irrational. They're not going to be pretty. You know, it's not going to be like 5 halves or anything like that. This weird root jacks it all up. And we're all done like that. And if you graphed it, it would look something kind of like that. Although this picture wouldn't be quite accurate because for this particular graph, what would it do? This one would open down, right? So I guarantee you this would look something like this, and it would cross at 2 real, distinct, different spots that are not pretty, and that's the whole point of today. All right, let's do some LGs and review those one more time, maybe do some example problems together, and then that'll be it. Continue to review for the test. That's your goal. Continue to review. Very important review stuff today. Very handy skills that will continue to follow you through units in the future as well. Just solving quadratics in general. How do you solve a quadratic? You can factor it, you can complete the square, you can get in vertex form. Don't even worry about that really. You can do quadratic formula. Lots of ways to do this. And that's really all algebra is going to break down to. There's not a lot more under our toolbox. You might think we have all these fancy techniques to solve fancier things, but they really come down to, can you solve linear things, lines, like 5x plus 2 equals 0 or something like that, or quadratic, like anything we've been studying recently, ax squared plus bx equals c or something like that. All right, review assignment due on Thursday, of course. Don't forget about that little gem. I'll tell you what problems to be focused on tonight, and we'll try to stay on task. If you do a little chunk every night, it should not be sneaking up on you, and you should be totally fine to go. Okay, let's get back to the review. Section 3.4 is where we're left off yesterday, solving quadratic equations by factoring. So there's not much else to say about this except for how do you factor. Don't forget the two main things for factoring. Number one, see if there is something they all have in common and factor it out. There's a number involved everywhere. Try to factor that out. If it's a variable involved, everybody try to factor that out. After that, really the only techniques you have to factor are with quadratics. You're kind of left with something that might look like this. And if you're left with something like this, then what do you try to do? You try to find two numbers, right, that multiply to be the last one, right? And at the same time, add to be the middle one. So start writing down combinations. You know, it could be 1 and negative 15. That would work, correct? It could be negative 1 and positive 15. Anything else that goes into 15? Maybe 3 and negative 5? Or negative 3 and positive 5. You know, any of these combinations would multiply to be negative 15, but only one of them will add to be negative 2. And that would be this one right here, correct? So find the right combination. If you got to sit down and write things out, that's fine. There's no problem here. But once you found the numbers, then you just write them down. 3 and negative 5 fit the bill. Negative 5 plus 3 is negative 2. Their product is negative 15, so we're good on that. And remember, the whole reason we choose to factor, very important, is that it's easy to spot when the factors themselves are equal to the magic number of 0. So be really conscious of that. Any questions over factoring? I don't think so. You pretty good on that? I think so. Let's do an example problem then. So let's see. We left off on 15. 16, 17, 18, they're all kind of dedicated to factoring. Does any of them look pretty bad? I mean, if you think you got it, we don't have to do example problems, but is there anything you think looks scary? Nothing? All right, we'll save some time then. So yeah, again, just make sure you set it equal to 0 first. Factoring is useless if you don't have it set equal to 0. So move everything to one side, factor variables out, factor numbers out, and things like that, and you'll be just fine. All right, the other skill that is probably more scary to me is there's a couple things on the test I worry about. This is one of them right here, completing the square like this. Again, completing the square is just a formula, okay? It just, these two are equivalent. If you took this thing and actually distributed it out and wrote this times itself and distributed it out and cleaned up and put like terms, these two sides would be equivalent. The whole point of completing the square is you can take things that are x squareds and x's, right? It's like a mix of them, right? It's x squareds and x's, and you can turn into just one thing with just x's that are squared. And if you can get this thing by itself, then you can take a square root and undo it like that. So let's look at a pretty typical example. This is probably something more along the speed of the test I would give you right here, something like this. No leading term, right? It's just a 1 right here. That's pretty easy. When you complete the square, make sure you just concentrate on the first two things and just religiously use the formula. That's really all you have to do. B would be negative 4, correct? So over here, I'm just going to rewrite this with b being negative 4. So these two is equivalent to x. If b is negative 4, what's negative 4 divided by 2? Negative 2, right? Plus negative 2, that's kind of stupid to say. Why not just say x minus 2? So the first term, when you plug in the b over 2, you get negative 2. And then make sure you also subtract. You're not done. There's another part to this. Subtract whatever that number is squared. So if that number was negative 2, what's negative 2 squared? It's 4. So that right there, these two is completing the square into this. I'm just literally using the formula. That's not so bad, is it? That wasn't so bad. That's kind of what I'll give you on the test. Of course, you still got numbers over here, 9s and things like that. Combine like terms, you know, this is 5. Get the squared thing by itself. That's the other thing to worry about. Because you're trying to get the squared thing by itself so you can undo it with a square root. So take a square root of both sides. Don't forget your plus or minus. Square root of a negative, you should automatically be putting i's by now. You know, but square root of a negative is just going to be an I thing. Try to simplify your roots if you can. Now, none of these perfect squares go to 5, right? So we're good, but be thinking about that. I don't want to dock you like a half point or something like that because you look like a square root of 8 or something like that. And then just do whatever you got to do to get the x by itself. So here's my 2 answers. If you move the 2 over, it'd be 2 plus or minus the square root of 5i. And that's all there is to completing the square. Those are problems 19, 20, and 21. Would you like to see one of those done? I bet you want to see completing the square done, don't you? No? Come on. 20? Let's do 20. Sure. All right, here's a freebie for everybody, number 20. Let's see what you guys got. Starts off saying x squared plus 8x. That's the part I care about, correct? I could put any number after that. It really doesn't matter. I could put a plus, 55,000. It doesn't really matter because the thing I'm concentrating on with completing the square is the first 2 terms. All right, so what's b? Obviously, b is 8, correct? So over here, I got a lot of b over 2's floating around. B over 2 would be 8 over 2 or 4. Okay, so I'm going to replace this with x plus 4 squared. Oh, that's 4. Minus, and then 8 over 2 is 4, and 4 squared is 16. So I've completed the square. I took these 2 and turned them into this by my little equation. Make sense on that? I don't think I think dang genius there. Now, always be combining like terms. Like in any step, if you see 2 numbers, put them together. If you see a 5x plus 7x, call them 12x. No matter what, I don't care what we're studying. Like terms go together all the time. So these 2 go together to be -4. And the whole thing I'm trying to do is get the squared thing by itself. So let's move the 4 to the other side. That would make it x plus 4 squared equals +4. And now we got the squared thing by itself. We can undo it with a square root. So when you take a square root of this side, the square is gone. Taking the square root of the other side is the square root of 4 pretty. Yeah, it's just 2, right? And don't forget your plus or minus. You take a square root so consciously, you have to be thinking about that. I gotta do that. Because how many answers should I have? This is a second degree. I should have 2 answers. If I don't have 2 answers, something ain't right. All right. At this stage, just move the 4 to the other side, and you got -4 plus or minus 2. Now, this is actually something you could go a little bit farther on. There's no, that's pretty easy to do, the plus and the minus. If you do the plus version, -4 plus 2, that would just be -2, correct? So one answer is just x equals -2. If you do the minus version, -4 minus 2 would be -6. So if you can go a step farther, don't leave it as a plus or minus a number. That's pretty easy. You can do plus the number, you can do minus the number, and you get out 2 specific answers, and those are the answers. So there you go, x equals -2 and x equals -6. Now, if you're not sure that you did that right, there's lots of ways to check these. So if I'm on the test and I'm not sure I completed the square right, I'd go back and try to solve it another way. Could you have factored this thing? Yeah, you could have. You could have factored this into x plus 6 and x plus 2. And what are the 2 answers for that? -6 and -2. Worked out, right? Same thing we got with completing the square. You could use the quadratic formula to check it. -b plus or minus the square root of b squared minus 4ac all over 2a. That's going to be -8 plus or minus the square root of, that's 48. That's going to be 12, 16, that's 2. That's -8 plus or minus 4 over 2. And if you kept doing it, guess what you get? You get -6 and -2. So there's lots of ways to check that you completed the square correctly. And if you have time on your test, I certainly would do that. I would go ahead and make sure that the technique I use is backed up by another technique right there. So that's it for that. And then, of course, the last thing to talk about today is just using the quadratic formula. But I'm not so worried about that. I'm more worried about just interpreting the discriminant, okay? But first things first, here is the quadratic formula. This will always work, okay? So if you're in a jam and you don't know how to solve a quadratic and you can do it any way you want, you got it. You can just plug things in here and it'll crank out the numbers for you and it solves it, which is pretty darn nice. A little bit tedious. Make sure if you have negatives, you put them in parentheses. especially right here, this b squared right here. Kids love to write, oh, b is -2. So b squared would be, they type in their calculator this, -2, and they put square. That will not work because it's going to square the 2 and not the negative. So if you have to put a negative in parentheses to square it, please do so right there. Other than that, just keep simplifying as much as you can. Make sure you look for perfect squares that might go into your roots and things like that to simplify them. And if you have squares and negatives, that's okay. Just call them i's. What should you know about the discriminant? That's the key thing here. The discriminant is the stuff under the square root. And this little table up here, this is gold right here. I don't think I'll put this up on the test, but you do get to use your notes. So if you want to write that down somewhere in your notes prevalent to you and say, oh, okay, I can just look that up real quick. Here's what it says. Number one, if your discriminant is positive, that means on a graph, like in the warm-up, it's going to cross at 2 different spots right there. So you will have 2 real, distinct zeros. There will be 2 spots where they cross right there. If the discriminant is active, remember the discriminant is the stuff under the square root, right? So if the thing under the square root is pretty, like the square root of 4, well, what's that going to turn into? It's going to be something nice and clean, right? And then you're going to get a nice clean answer out. So if the discriminant is a perfect square, so it's 4, 9, 16, something like that. If it's a perfect square, then you will get out not gross roots, but pretty roots, which will turn into pretty fractions. So that means it'll be rational right there. It'll turn out to be clean numbers, 5, 6, 9, 11s, something that can be written as a clean fraction like that. On the other hand, if you were stuck with, I don't know, a square root of 17, for example, that's not a perfect square. So you're going to have these weird answers left that are not going to be written as that. So if not a perfect square, they will not be pretty. They will be one of those things like pi or something like that that just goes on forever, 3.1415926, and you get something like that. So when you get a discriminant more than 0, well, you need to write to me. You need to tell me there's 2 real distinct zeros, okay? But you also need to tell me if they are rational or irrational based on the fact whether this is a perfect square or not. If your discriminant equals 0, then that is a sign to you that this graph will cross only at 1 spot right there. You will have 1 real repeated 0. 1 real repeated 0. That means they'll be there twice. So if you did the quadratic formula, you get at 5 and another 5 or something like that. You get at 20 and 20 or something like that. And that means on a graph that's only going to cross at 1 spot. Lastly, if your discriminant is less than 0, remember your discriminant is the stuff under the square root, then if the thing under the square root is negative, less than 0, that means you're going to have imaginary stuff and complex answers. So you get 2 complex, they'll be different. They will also be conjugates of each other. There will be 2 weird things like maybe a 5 plus I and a 5 minus I, or a 20 minus 19i and a 20 plus 19i, something like that that's complex and conjugates. Since they're complex, you will not really see a spot where they cross. It's not a real number where they cross. So your graph will not cross the axis whatsoever in that case. So very important to understand what the discriminant is telling you and how to interpret it in terms of how many times it's going to cross the graph. That's the main theme for the discriminant. Other than that, you just got to apply the quadratic formula to it, and that kind of concludes for today. So all this discriminant stuff and the zeros and all that stuff is 22 through 25. Anybody want to do one of those real quick? Doesn't look that bad. Come on, give me one. I'm recording this for others. Give me one. Okay, thanks for arbitrarily picking something. All right, 23, here we go. F of x is x squared plus 6x plus 9. And the first thing they ask you for is the discriminant. So, again, the discriminant is b squared minus 4ac. So for us, that'd be what? 6 squared, which would be 36, minus 4 times a times c. And that's 4 times 1 times 9. Well, 4 times 1 times 9 is just 36, isn't it? And 36 minus 36 is 0. So your answer for the discriminant is 0. Write that down. Discriminant is 0. Now, for the, where it says type of zeros, that's where you do your writing. So based on the fact that discriminant is 0, here's what you need to write right there. There's going to be one real repeated 0. That's what you put in that slot right there. You look it up on the thing, write down exactly like it looks. Theirs even goes a step farther. They say one real repeated rational 0. That's even better if you want to put the word rational in there. Basically, you're just copying the chart, right? No big deal. So we got our discriminant of 0. Copying the chart says that that means there's one real repeated rational 0. The only other thing to do is actually find the zeros. Now, how do you find the zeros? This discriminant doesn't give you the zeros. It tells you what kinds of zeros you are. The thing that gives you the zeros is the quadratic formula. So you need to go do that in its entirety from there on out. And we'll do that right now. So doing the whole quadratic formula on this thing, x equals negative b, so that would be negative 6, plus or minus the square root of the discriminant, which you just figured out was 0. So plus or minus the square root of 0 all over 2a, which is just 2. This is why there's going to be a repeated 0, and you can see it coming down the line. What's the square root of 0? It's just 0. So if you do negative 6 plus 0, you get negative 6, right? Which divided by 2 is negative 3. If you do the minus version of it, negative 6 minus 0, it's still negative 6, which divided by 2 is still negative 3. So that's what they mean by the repeated part. They mean that they're going to get the exact same answer out twice. There's only one answer, negative 3. It just happens to be there twice from the quadratic formula. And that is rational. That can be written as a fraction. I could just write that as over 1 if I wanted to or something like that. But as predicted, one real repeated rational 0 on that. Any questions already? Okay, that kind of concludes for today's review. Your goal should be pretty much to get through that section. So if you can get through 25 by the end of the day, that'd be a really good pacing for yourself. Tomorrow we will finish up the review. We will be talking about inequalities and all that more recent stuff. That shouldn't take very long. Test is on Thursday, so keep up the good work, everybody. Have a good day.